Happy Friday, guys. I hope you're having a great day so far. I cannot wait to see you all on Tuesday, and I hope you have a fabulous 3-day weekend. Today we are going to be talking about the area of circles. Don't forget to do your homework, 3.4 homework that you can always find on GoFormative. And don't forget to write your learning targets in your notebook. I know and can apply the formula for area of a circle. Get that all written down like you're supposed to. Come back once you're ready. All right. So let's go ahead and start our warm-up. Irrigating a field. A circular field is set into a square. This square has a side length of 800 meters, and we're going to use this to estimate the field's area. We do not know how to find the area of a circle yet, which is why we are estimating it. We know that since the circle is inside the square, that the area of the circle is less than the area of the square. So go ahead, try this, come back once you're ready. Okay, so again, we know that the area of the field, the circle, is going to be less than the area of the square. So if we find the area of the square, we know it's going to be one that is very close to it, but less than it. So to find the area of a square, we take the side length and multiply it by itself, because both the length and the width are going to be the same. So we are going to do 800 times 800. Which is 640,000. So we know it is going to be less than that. We don't know exactly how much less, but we know it's going to be very close to it. So that is why we're going to estimate about 500,000 meters squared. Okay. All right, now let's go ahead and actually talk about how we find the area of a circle. Now, I find this very cool. I understand you guys might not, and it's just because I'm weird, but I was never taught where we get the formula for area of a circle. I was just taught the formula. I was forced to memorize the formula and just plug and chug. So I really wanted to show you guys where we actually get the formula from. You don't have to memorize, like you don't have to know this for your test, but I just think it's really cool to know. So you have an applet that gives you this circle, and then you can like cut the circle down like it's doing here, and then it folds out into this shape. So we want to know, I'm just going to go through this so you're not going to have to pause. So our first question is, what does this new shape resemble? What does this kind of look like? It looks like a pyramid, but a pyramid is a 3D shape, okay? Like we see the stepping stones, kind of looks like a pyramid. But the 2D version of it would be a triangle. So for number 1, we're going to put triangle. Okay, it kind of looks like a triangle. Now, we're missing some, but it looks like a triangle. So now we want to know, how does the area of this shape compare to the original circle? Well, that's obvious. All we did was cut and change the shape. We didn't like take pieces of the shape away. We cut it down the middle and unfolded it, but we didn't take anything away. We didn't add anything new. So the areas are the same. The areas are the same. So now we want to know, how can we find the area? This is where we get the, how we actually get the derivative, like where the formula for a circle comes from. Okay, so kind of cool. Okay, if it doesn't make sense to you, Eric, go away. If it doesn't make sense to you, that's okay. Just kind of stick with me for this part. So first of all, triangles. We know to find the area of a triangle, we take 1/2, multiply it by the base, and multiply it by the height. Okay, we should know this. We learned it last year. Now, this is where we change things up a bit. Okay, the base of our triangle right here. We notice this is the piece that goes around our circle. The outside of our circle is the circumference. So our base is the circumference of our shape, of our circle, sorry. Now the height of our circle, okay, it goes from the middle to the outside. From the middle to the outside of the shape is the radius. I'm sorry, I keep calling it the shape because we're talking about two different shapes. So from the middle to the outside of our circle is always the radius. So our height is the radius of our circle. Okay, now we need this to now get the formula. So base B, I'm going to replace it with how we find the area of the, the actual circumference of a circle. So we find the circumference by taking pi 3.14 and multiplying it by the diameter. I'm going to replace our height with what the height is. It's the radius. Okay, so now I have 1/2 times 3.14 times diameter, which is the circumference. Okay, these are the same. And then times the radius. Okay, I replaced our base with the fact that it's the circumference and the height with the fact that it's the radius. Now we're going to do a little bit more. So we know that half of the diameter is always the radius. So we can multiply 1/2 times diameter and get the radius. So now we have, now we have 3.14 times the radius times the radius. Okay, we can shorten radius times radius to be radius squared. Okay, these are the same. Okay, you're gonna see something like this on your formula sheet. Okay, but instead of 3.14, it has the pi symbol. But it will be radius squared. But remember, radius to the power of 2, radius squared is just the radius times itself. Okay, so now we're going to actually apply this formula. I'm going to do the first problem, and then I'm going to do it. And so you're just going to follow along, write it down, and then on the next few slides, you're going to try it yourself. So we have 5 centimeters as a length. It goes from the center to the outside. So we know that this is the radius. And for the heck of it, you know, because you guys are going to have to do it on your test, I'm going to go ahead and I'm going to say what the diameter would be as well. The diameter is going to be twice the length of the radius. So 5 times 2 is 10. Okay, we don't need this for finding the area. But again, since you are asked that on your test, it is really good to just practice it. Now, we're going to use the radius, plug it into our formula, and find the area. So we are going to do 3.14 times the radius and times the radius again. 5 times 5 is 25. And pi times 3.15, let me check my answer key, is 78.5. So this is 78.5 centimeters squared. Okay, it's that simple. That's it. That's all we got to do to find the area. It is a little more complicated than the circumference, but all we need to do is multiply the radius times itself and then multiply it by pi. Okay, and you will have these formulas on your test, so you don't have to memorize this. We just need to practice it a bunch, okay? Get this down, and then let's go ahead and move on to our next slide, and you're gonna try this one yourself. Okay, so again, we have a circle, okay? Our length is 15 centimeters. Beautiful practice. Tell me the radius. Tell me the diameter. And then find the area. Okay, pause here, try this, come back once you're ready. Okay, so the 15 centimeters that is given to us is actually the diameter. So our diameter is equal to 15 centimeters. The radius is half of 15, so we're going to divide 15 by 2, which is 7.5. And now we can use that radius to find our area. So pi 3.14 times 7.5 times 7.5 again. Now 7.5 times 7.5 is 56.25. And now we're going to multiply 56.25 times 56.25 times pi, which is going to be 176.625. Okay. Now make sure you're not using your diameter finding your area. We only use the radius to find the area. Diameter is for circumference. Area is for our circle. Or I'm sorry, area. Radius is for this area. Lord. Okay. Let's go ahead, move on to the next problem. And now we're going to start talking about real world problems. So a circular rug has a radius of 72 inches. What is the area of the rug? Again, good practice. Tell me what the radius is. Tell me what the diameter is. Then go ahead and find the area. Pause here, come back once you're ready. Okay, so first of all, it tells us that 72 is our radius. It goes from the center to the outside. So our radius is 72 inches. Our diameter is twice the size of the radius. So we're going to take 72, multiply it by 2, and get 144. And now we can use our radius to find the area. So pi times the radius again. 72 times 72 is 5,184. And now we can do 5,184 and multiply it by pi. That gives us 16,277.76 inches squared. Okay. Don't forget, I just realized I've taught you guys this before, but we haven't used it in a while. To insert an exponent, you're going, or to type out that you're doing an exponent, you can do control period. Okay, and then it'll go up into the script, and then control period again to undo that. Or, okay, remember the caret key. So you would do inches, caret key, 2. And it won't make it little, okay? But what this does is it notates that it's going to be an exponent. To put an exponent into GoFormative, that's what you are going to do, okay? It'll automatically make it into an exponent, make it tiny up in the corner. And that's how you can insert the correct label into GoFormative. Great job. Once you got all this down, let's go ahead. We only got 2 more slides. Let's move on to a $50. So not many of you have probably seen a $50 because they're not that common, but there are $50. Okay, so it's half a dollar, it's 50 cents, which is why they are called a $50. Now, $50 have a diameter of 1.2 inches. What is the area of a $50? So they are a little bit bigger than a quarter. I don't know, just fun fact in case you've never seen one. Don't forget, tell me what the radius is, tell me what the diameter is. Get in the practice of it. Try the problem, come back once you're ready. Okay, so first of all, they give us 1.2 inches is the diameter. So obviously, putting that under diameter. Our radius is half of this. So 1.2 divided by 2 is 0.6. And now we can use 6/10, 0.6, the radius, to find our area. So 3.14 times 0.6 times 0.6 again. I'm sorry, it's hard to write with my camera in the way. Now 0.6 times 0.6 is 0.36. So we have 3.14 times 0.36. Now pi times 0.36 is a decently long number, but there's only 4 numbers after the decimal, so we're just going to leave it as is. 1.1304 inches squared. So just slightly more than an inch, okay, of area. So bigger than a quarter, just still kind of tiny. Get all this down. And let's go ahead and move on to our very last problem, which is pretty cool. I don't know. I saved it for the end because I thought it was a pretty nifty problem, and it is I actually copy and pasted a lot of the information directly from Google because this is real, okay? So the Barringer crater, also known as meteor crater because it was formed by a meteor, is a 1,300 meter diameter hole in the flat-laying desert sandstones 30 kilometers west of Winslow, Arizona. So it's out in the desert somewhere, thank God, because it really would have messed up like a lot, like quite a few houses, if it was to actually crash into like a neighborhood, a city, something like that. So it was out in the desert, about 30 kilometers away from a town. To be honest, I should have Googled that in miles, because I don't know how big a kilometer is. I think it is smaller than a mile, but I'm not sure. So if you want to Google that and then actually email me, that'd be kind of cool. But anyways, so I want to know what is the area of this giant crater that is in the middle of the desert. And here's a picture of it. I don't know. I just thought it was cool. So don't forget, what's the radius? Tell me what the diameter is. Come back once you're, find the area, and come back once you're ready. Okay, so first of all, it tells us that the diameter is 1,300 meters. So I shortened meters with a M. Now, our radius is going to be half that amount, which is 650 meters. I do know how big a meter is. A meter is just slightly over 3 feet. So 1,300 meters is going to be slightly over 3,900 feet, okay? So quite, very, very big, okay? So now our area, we are going to do pi times our radius, which is 650, and times 650 again. 650 times 650, so we're going to get some pretty massive sized numbers here. So make sure you have all the correct digits. So 3.14 times 650 times 650 is 422,500. Now, when we multiply these together, we're going to get an answer in the millions. 1,326,650 meters squared. Hello, hair. Okay. So, yes, very massive. Very, very big. And that's it. That's all we had to do. Okay? Pretty quick, pretty painless. If you guys have any questions, you can email me. I should have my computer and my phone on me today. So just email me if you need help or anything. Okay, guys? Alright, I miss you bunches. Hope you're having a great day. Cannot wait to see you on Tuesday. Actually, I'm sorry. Pause. We need to do our lesson synthesis. Don't kick me out yet, please. Okay, lesson synthesis. go ask whoever is in my classroom currently. Okay, shout out to all the teachers subbing for me today. Go ask them for the lesson synthesis. Okay, so the formula for the area of a circle is area is equal to pi r squared, or 3.14 times the radius again, which is what we were doing the entire lesson. So for this circle, we are given the diameter. Since the diameter is 16 feet, that means our radius is 8 feet. We can now use the radius to find the area. So we plug in, instead of r, we now have 8. 8 squared is 8 times 8. 3.14 times 64 gives us 296 feet squared. Okay, now we can do what I was planning on doing. First thing you now need to do after you get your lesson synthesis from the lovely teacher that is in my room is your cool down. Then you need to do your lesson synthesis. After your lesson synthesis, 15 minutes of Edmentum. Please do Edmentum. And last but not least, number 4, you can now do a homework. Now, after homework, please make sure all other homeworks have been complete, along with go-formatives that are not at 100%. So some of you need to go make corrections to 3.2 homework. Okay, that was the homework from Wednesday. Yeah, the homework from Wednesday. And also cool down. I meant to say cool down. It's been a long day, guys. Okay, I just made it through the video. Now I can go to bed. So, get all this done. If you get all this done, you get choice board time, which is the last slide of the lesson. Okay, most of you are gonna do Prodigy. Okay, a lot of you actually do chess. Back up, a lot of you do chess. That's cool. Do chess. Okay, do something on the choice board. Okay, thank you for being great, wonderful human beings. I love you all. Have a great weekend.